Alright, what's up guys? In this video I'm going to pick up some multivariable calculus. We're on the topic of functions of several variables, and this is more or less an application question within this chapter. So we're asked to consider the block of a conducting material occupying the following region D. So D here is the region. And it basically says that the temperature in the block is given by the following function of three variables, which is 250 xy sine of pi z. The volume of the region D is going to be 4, and they want us to find the average temperature of the block, basically. And so, again, V is just going to be the volume of the block. Okay. So to find the average value, we just use the following formula. So we use the formula for the average value of a function with several variables, which in this case happens to be 3. And that's just going to be equal to 1 divided by the volume of the region. And then we'll have our triple integral. Again, D is the region, and we'll integrate the function. That's the formula we're going to use to find the average value. Okay. So in our case, if we actually set it up, we'll have our triple integral. This will be 250 xy sine of pi z dv, and we just need to set up the triple integral and evaluate it. Now we know we're going to be integrating in this case dz, dy, dx. So since we're integrating in that order, I'm going to pull out the 250 as just as a constant, and since we know we're integrating from that order, that'll be the integral from 0 to 2, the integral from 0 to 2, the integral from 0 to 1, and then we'll just have xy sine of pi z, and again this is done dz, dy, dx. So it's just a triple integral here. Okay, alright, so let's go ahead and do it. So for triple integral, we, in this particular circumstance, are going to start by integrating with respect to z first, treat the other two variables as constants, and much like for the doubles, you work your way from the innermost to the outermost integral, and that's pretty much how you do it. So since we're integrating with respect to z first, I can pull out xy, okay, and it's just going to be the integral from 0 to 1, and then we'll have sine of pi z integrated with respect to z. So xy, again, that's just a constant. The antiderivative of sine of pi z dz is just negative 1 over pi cosine of pi z, and we evaluate it from 0 to 1. Now notice here, if we stick in the 1, and I know the xy is out there, but I'm just kind of going through. Notice that if we stick in the 1, we'll get 1 over pi. If we stick in the 0, we'll get negative 1 over pi. So this is essentially 1 over pi plus 1 over pi, which will give us 2 over pi. But we do have to multiply by the xy on the outside. And so now, if we multiply by the xy on the outside, we would now get down to our double integral now. Okay, so now we have, and again, the 250 is on the outside. So it's going to be the integral from 0 to 2, from 0 to 2, and we'll have 2xy all over pi, and it's dy dx now because we took care of z. Okay, alright, so since we're integrating with respect to y, remember what we can pull out. We can pull out the 2x over pi. Remember, pi is just a constant, it's just a number. Then we'll have the integral from 0 to 2, and we'll just essentially leave the y in there. So this becomes 2x over pi. It's going to be y squared all over 2 if we apply the power rule. And it's going to be from 0 to 2. If we stick the 2 in, we'll get 2 squared, which is 4. Divide that by 2, we'll get 2. And obviously, if we stick in a 0, we'll get 0. So essentially what we got now is 2x pi multiplied by 2, which obviously will give me 4x pi. Now we're down to our single integral now, so it's going to be our constant 250, which we pulled out earlier, and it's going to be from 0 to 2, and we're going to be integrating 4x over pi with respect to x. So again, the 4 over pi can come out, as that's just a constant. This becomes x squared over 2 if we use the power rule. And again, this is from 0 to 2, so we already know that when we substitute in, much like we did for the y's, we're just going to end up getting 2 if we plug in the limits. And so essentially you would have a 4 over pi multiplied by 2, which we know gives us 8 over pi. Now we need to take our 250 and we'll multiply that by 8 over pi. And we see what we get. So I'll check, use my calculator here. So we get 2,000 over pi, basically, if we do the simplification. Okay. So now that we get 2,000 over pi, now remember, they gave us the volume of the region D. So the volume of the region D was 4, if you remember from the beginning of the problem. So essentially what we have is 2,000 all over pi, and we'll divide that by 4. And that's just going to give me 500 over pi, which in your calculator, I should put it in here. It's about we'll say approximately 159.2. We'll say approximately. And that would actually be, that would be the average temperature of the block. So our final answer here, we tried to find the average value of the function of several variables. So our answer here is going to be approximately, because we just kind of rounded, 159.2 or 500 over pi. And that is how you do it. So pretty straightforward. So if you're familiar with how to evaluate triple integrals, this shouldn't be too bad. We just had to use the formula. All right, guys, that's going to be it. I'm going to see you guys next time. Y'all take care.